In this video, we'll return to our discussion of the basic unit vectors I, j, and k. And now that we have vector addition and scalar multiplication, we can make more connections between how we can use these vectors I, j, and k in practice. So recall I, j, and k are defined this way. And you should think about I as kind of pointing along the x-axis, j along the y-axis, and k along the positive z-axis. And the basic idea of this video is that every vector is a linear combination. And I'll explain what that means. Is a linear combination of these three vectors I, j, and k. So if you give me any vector v, its components are v1, v2, and v3, and I can use that to write the vector in terms of I, j, and k. And this expression here is called a linear combination because I'm scaling these basic vectors I, j, and k, and then adding them together. That's what we mean by linear combination. Scalar multiplication combined with vector addition. And if you take the time to write this out, v1 times I hat means just to scale this by v1. All the other entries are 0. So that first vector is v1, 0, 0. And then I add to that 0, v2, 0, just scaling this one by v2. And then similarly, I have 0, 0, v3 for the third vector. And if you add those all together, just by the way that those zeros are lining up or not lining up, you get the vector v1, v2, and v3. So I can either write a vector in component form as v1, v2, v3, or I can write it as a linear combination of I, j, and k, and those scalars in front of each of those basic vectors are v1 and v2 and v3. So you'll commonly hear me call v1 the first component of a vector. I might refer to it as the I component, and the second one is the j component, and the third one is the k component, because it's telling you how much of each one of those vectors are included in the sum. Let's make this as concrete as possible with an example. I have the vector u, and I've written it in component form 2, negative 3, and 0. I could then choose, if I wanted to write that as twice I minus 3j, and there's no k component. If I have the vector v and it's written in this form, so vi plus 2j minus k, I could just interpret that as 4, 2, negative 1 in component form. And whatever version you use is entirely up to you. These are stylistic choices about how we write vectors, and we will move back and forth between these different notations. So if I wanted to perform operations, like for example, if I wanted to subtract these vectors, I could either take them in the component form as it appears here with the angled brackets and just subtract components, or sometimes it's kind of convenient to think about this as just some algebraic expression in these i's and j's and k's. So the first one is 2i minus 3j, and I subtract from that 4i plus 2j minus k. And I could just think about this as kind of combining like terms. So I go 2i minus 4i, and that gets me minus 2i. Just thinking of it as like polynomials or variables and combining their like terms by subtracting the coefficients. If I have minus 3j and then distributing the minus to the 2 here, I'll get another minus 2. That gets me minus 5j. And then there's no k's over here, so it'll be plus 1k. And I could write it as minus 2i minus 5j plus k. That's the same thing as just subtracting the components, minus 2, minus 5, and 1. Again, it's stylistic what you prefer. Just make a choice and use it, mix it up a little bit as you're doing examples, and either is suitable.